Okay, well, with our last video, I'm sad to say I'm not sure where exactly it ended. Evidently, I hit the pause button, perhaps inadvertently. But we've got the equation of the tangent plane to a level surface. You can see that it's really going to be what I've highlighted up above. F sub x, f sub y, f sub z. This is coming from the gradient. And of course we're plugging in, we're substituting in an initial point. But this gradient is perpendicular to the plane, and then we just will dot product it really with a position vector of x minus x naught, and that would be any position vector on the plane. But very quickly you might follow up with a normal line. Let's have a little bit of review from chapter 12. If you want to have the equation of a line in space, hopefully you remember this is going back a number of weeks now. It was x naught plus at, y equals y naught plus bt, and z, parametrically writing all these out, would be z naught plus ct. And what we had, of course, was a point which was x naught, y naught, z naught, and we also had a direction vector. This direction vector would point in the direction of the line, of course. And what we're seeing is we could write a symmetric equation of a line by subtracting x naught here, dividing by a, subtracting a y naught from both sides here, dividing by b then, and then subtracting a z naught and dividing by c. Well, what are we getting at? All of these t's, of course, would be equal, and that would lead us to x naught all over a would equal y minus y naught all over b would equal z minus z naught all over c. Of course, ABC is the direction vector. Well, we're going to look at a normal line right now. A normal line, it's a line passing through P, and it's perpendicular to the tangent plane, as we can read here in this definition. The gradient vector is the direction vector. It's the direction of the normal line, and we can see that if we scroll back just a little bit. The direction vector, the gradient of f, I've taken that away real quickly, but you can see that was our normal line. The gradient would be pointing in the direction of that normal line going through point P. So, just as we had before in ABC, our ABC components are actually the partial derivatives. So this is writing our normal line symmetrically. Well, let's real quickly finish up just this last problem. Find the equations of the tangent plane and the normal line at a given point, -2, 1, and -3. Well, as always, I just want to point out that really this is, like we had before, just at the beginning of the lesson, interpreting this as if we had a level surface for a function x, y, z, setting that equal to 3. There's no need to subtract a 3 here, but what we will do is take our partial derivatives for this function of x squared over 4 plus y squared plus z squared all over 9. So that's where we'll be taking our partial derivatives. Let's do that quickly. Also then substitute in our initial point. So f sub x, the derivative of f with respect to x, will bring down the 2. We'd get x over 2. Everything else is going to cancel out in this function. F sub y, well, we can look right here and see how do we take the derivative with respect to y. We'd get 2y. Anything with the x and the z terms over there are constants. They actually disappear. we'll take our derivative with respect to z. We'd get 2/9 z. Now I'm going to substitute in the point -2, 1, 3. That might look a little funny, especially because we only have one variable in each of these partial derivatives. Well, very often we'll have multiple variables, but this would be -2/2. This would become -1. Plugging in a 1 in for y, 2 times 1 is simply a 2. Finally, plugging in a 3 for z, we'd get 2 times 3 is 6, 6/9, but reducing that we'd get 2/3. Well, what we saw for the tangent plane, we saw had the partial derivative of x times x minus x naught plus the partial derivative of y times y minus y naught plus the partial derivative of z times z minus z naught, and set all that equal to 0. Well, we just saw that f sub x is -1, and here we'd have x minus -2, so that turns into an x plus 2. F sub y is a 2, and we'd be left with y minus a 1. Finally, we have this fraction of 2/3 for f sub z. This is z minus -3, which turns to z plus 3. This answer is perfectly acceptable. There's nothing wrong with it whatsoever. However, I want you to notice that very often in the back of the book, the author will multiply out fractions. And that, of course, isn't necessary, but it does make things look a little bit nicer. And the form that we get, multiplying every one of these groups by 3, would be -3x plus 2 plus 6 times x minus 1 plus 2 times z minus 3. Both answers are great. Finally, last part, we need the normal line. Well, the normal line, the funny thing is we just had our x minus x naughts written all over the place. You're going to see that in the tangent plane. You have parentheses around them everywhere. So writing this symmetrically, and that's maybe one of the advantage of the symmetric form, is that you're going to be able to look at the equation of your tangent plane and very quickly write the equation of the normal line. Especially as we come up here to our first form. Up here we can say, well, wow, look at all those parentheses with our variables. That is exactly what we're going to see right now. We're going to have x plus 2, and we're going to divide by f sub x, which is -1. And we have y minus 1, but we're going to divide by f sub y, which is a 2. Then we'll be left with z plus 3. We're going to divide by our 2/3. And it's okay to write a fraction down there. Of course, we could, have put the 3 up on top. That would be fine. So hopefully this is making plenty of sense for you. You might want to check with a friend. They did take some pictures of the answers to the evens on the homework. I wrote that on the whiteboard. I don't have a smartphone, I'm sad to say, so they were able to use theirs in that way. Also, please don't forget, on Tuesday, we're going to have our ILML contest, first one of the year. Won't be able to remind you on Monday, though. Wanted to let you know about it. Hope you have a great weekend. Best of luck to you.